Welcome back to our video series. In the last video, we explored how multiple faults interact with younger and older structural groups, and how modifying the fault relation matrix affects the results. Now we will examine interactions between faults. To showcase fault interactions, we create a new model, loading a fresh dataset from CSV files. This model contains three structural elements representing rock units: rock 1, rock 2 and rock 3. We place all of these into a single structural group named strat series. Additionally, we introduce three structural elements representing faults: fault 1, fault 2 and fault 3. Just as rock units can be grouped into structural groups, fault elements can also be grouped exactly the same way. Grouping faults forces them to be interpolated using a single scalar field, ensuring a more parallel behavior. This is useful for faults that should not intersect each other and that are linked to a similar tectonic event. In this example, fault 1 is placed in its own structural group. Fault 2 and fault 3 are grouped together in the youngest group within the structural frame. As before, we must set the bottom relation of the fault groups to fault. Here's the resulting structural frame and a 2D cross-section of the input data. By default, the fault matrix does not allow faults to affect each other. We need to change this by resetting the relation matrix so that the younger fault group affects the older one. Now let's compute the model and examine the result. Here's the cross-section. Let's discuss a few key features that emerge from our new settings. First, since fault 2 and fault 3 are in the same structural group, fault 2 follows a parallel path to fault 3, despite lacking orientation data. This happens because interpolation is performed with a single scalar field for the entire group. So fault 3's orientation data also influences fault 2. Second, fault 1 is now terminated by fault 2 because we explicitly set this relationship. This setup demonstrates how multiple interacting faults and fault groups can be structured within a model. A word of caution: fault relationships can quickly become very complex in Gempy. We strongly recommend starting with simplified models that focus on the most dominant structural features. After validating results, gradually increase complexity, adding one fault at a time, while making sure that the desired fault behavior is achieved. From experience, this is the best way to maintain model stability. We hope you found this final tutorial on faults helpful. If you did, leave a like on this video and consider visiting GitHub to give Gempy a star rating. Are there any topics you'd like us to cover? Leave a comment below. And don't forget to subscribe so you never miss an informative Gempy tutorial in the future. See you in the next video.